to introduce you to Ana Benítez, who is going to give the lecture today. Ana did her PhD until 2014 at Iraq, working with sand grails, spatial ecology and demography. And since then, she's been expanding her research to more global ecology issues. She moved to Radboud University in the Netherlands to work on the impact of global change in tropical areas, particularly of hunting. So she analyzed several global change stressors, and she moved a bit towards conservation biogeography. Then she had a Juan de la Cierva at the biological station of Doñana, working on the cascade effects on tropical forests, which is what she's going to talk about now. And she's currently with an emergia at Granada University working on scaling herbivory networks, although she will move to the museum in a month and a half or 2 months.
Yeah,
okay,
2 months.
So Ana?
Thank you,
Yes.
Joaquin. Thank you for the invitation, Rob. It's a pleasure to be here talking about my research today. The outline of the talk is, I'll be talking about how to quantify vertebrate defaunation and what are the consequences of defaunation for ecosystem functioning in tropical forests. And I have structured the talk in 3 major sections, which is what you see right here. But first, I would like to raise your attention to the last Living Planet report from WWF that was published 3 weeks ago. And here what you see is the Living Planet Index, which basically shows the trend in the abundance of vertebrate populations across the world for mammals, birds, amphibians, and so on. And what we see is that currently the estimates indicate that there's been an average decline of around 69% in vertebrate abundance for 32,000 populations that are included in this index. And this is not something that is homogeneous in the space. What we see here is that the most affected regions are located in the global south, mostly in tropical areas, which is the focus of my talk. So this process of animal loss, not species extinctions per se, but the decline in the abundance of populations, the local extirpation of some species is what we know as defaunation. And this is a term that was coined for the first time somewhere in the early 90s. And the main signature of this process is that it affects mostly large-sized species. What you see here is the body mass distribution of species that went extinct in the Pleistocene or have become extinct in the Anthropocene, which is the era that we're living nowadays. And those species that are threatened or non-threatened, they are much smaller than those that went extinct. And the main drivers of this process are well known. It's habitat modification, like exchange, habitat loss, and so on, and direct exploitation of the species, which is what the first part of my talk is about. So hunting, this activity per se, has been conducted in the tropical regions for millennia, but has become unsustainable nowadays for several reasons. One of them is there's been a great rock development in tropical areas, and that means that some of these previously remote areas have become accessible for hunters. And this has been accompanied by an increase in the human population growth that is demanding more and more wild meat and wild products. And also there's been a modernization of hunting techniques. So hunters do not hunt only with bow and arrow, but they use shotguns, rifles. They even hunt at night using lights and so on. And thus this allows them to transition from subsistence kind of hunting to feed their families to commercial hunting, which is exacerbated by this increased accessibility that I was talking about before due to road development. That means that some of this wild meat can be commercialized in rural markets and also in urban areas where it's sometimes considered as a luxury. Wealthy people in these areas demand this kind of products. So the extraction rates are estimated on about 65 million animals per year, or 5 million tons of animals per year, only in the Congo Basin. But as you can see here, extraction rates are very high also in other areas in the tropics, such as Indonesia, the Amazon Basin, and so on. So quantifying what's the impact of these extraction rates on animal populations is complicated. We came up with this idea of using the central place foraging hypothesis, which states that humans are mostly central place foragers. They gather resources around settlements or access points like roads. And this creates a gradient in hunting pressure that becomes lesser and lesser as we move further away from these access points. And then what we expect is that the species densities or abundance are much lower in the proximity of hunters' access points compared to remote areas farther in the forests. So using this idea, we conducted a literature review and a meta-analysis for the whole pantropical area, gathering a large number of studies and calculating this effect size, which is the response ratio, that is the ratio between the mean abundance of a species in a hunted area and the mean abundance in a control area, and then it's log transform. So when it's 0, it means that there's no change, and positive values means that there's an increase, and negative, a decrease in abundance. And we gathered this kind of information for almost, a bit over 250 mammal species and almost 100 bird species. So what you see here is the distribution of all the effect sizes for birds and mammals. Again, the 0 means that there's no change in abundance, negative values is a decrease, and positive is an increase in abundance. And we see that there's a bunch of species that have positive abundance in hunted areas, but there's way more species that have negative values, so they have a reduced abundance in hunted areas, and some of them even become extirpated thoroughly. If we back transform this index to the original scale, what we estimate is that in hunted areas there's an overall decline of 58% in abundance of bird species and 83% in the case of mammals. We also saw how we fitted also a model trying to see whether this effect size changed with the distance to hunters' access points. Of course, there's a lot of noise, and the size of the points is different because they indicate how precise are the estimates that were included in the model. So when the points are larger, it means that they weight more in the models compared to smaller data points. Overall, what we see is that for bird populations, they are systematically reduced within 7 kilometers from access points. And in the case of mammals, distances can go up to 40 kilometers. Think about elephants, which are actively persecuted for the illegal wildlife trade. These, hunters may travel to very remote areas just to gather these resources. So after publishing this paper, which is based on local hunting studies and then estimating the declining abundance of hunted species, I noticed, of course, that there are a lot of gaps across the tropics where we don't know anything about what's happening with mammal populations. So I wanted to try to see if it was possible to fit predictive models that could allow us to map defaunation across the tropics and see how the patterns would change for the species of different body size. So doing this for hunting is quite difficult. I mean, this is not like deforestation that we can track using remote sensing or satellite imagery, and we can see these clear patterns, visible patterns that form in the tropical forest where a road is built, and then there are perpendicular roads coming from the main roads to access new areas for extracting timber or for exploring other possible resources like natural gas or oil exploration and so on. So we can do this with satellites, and we have very high resolution satellite images nowadays, down to 30 meters. But in the case of hunting, this is a kind of a cryptic process that may happen under the canopy, and it could be happening in this type of forests, which are seemingly undisturbed from the sky, but they could be actually empty. And this is a term that was coined back in the 90s by Redford to point out to the fact that because of activities like hunting, some of the animal populations in these pristine forests could be actually a very low abundance or functionally extinct. And following this idea of having an intact forest and seeing whether it's intact or no, there are a couple of initiatives that have tried, well, there are more, of course, but in this case, I'm going to focus on these two that try to map intact forests across the tropics using satellite imagery, remote sensing, or in the case of the Human Footprint Project, using, besides remote sensing products, or using layers of artificial lights at night and roads and so on. But none of these initiatives consider explicitly overhunting. I mean, the Human Footprint Project, a little bit, they have this kind of proxy of decay distance from roads, but it's not really well, in my opinion, performed. So my idea was like, okay, if we manage to build these models for predicting defaunation across the tropics, can we pinpoint areas which are supposed to be intact, but they might be not? So what I did was to build upon the database they already had, expand it to include more studies, more mammal species, and more effect sizes. And in this case, I focus on a series of predictors that could be related to hunting pressure. Of course, this one, you know it already, is the distance to rural settlements. But then I also include the human population density, which is a proxy for the demand for wild meats and wild products. Also the travel time to major towns, which gives you an idea of how close are rural to urban markets where wild meat could be commercialized. I included an index of poverty under the assumption that some of these rural communities are heavily reliant on wild meat for protein acquisition. And also food security, because if you have access to domestic biomass, you may not need to hunt as much wild meat as you should. And then I also include the protection status of the area. So this is the scheme of the model. I mean, you don't have to really go deep into it, but what I want you to focus is that I match the locations of all these hunting studies and all those estimates of abundance with the socioeconomic variables that you saw in the previous slides. And then I included information on species traits, mostly diet, but also body mass, which is a proxy for the vulnerability to hunting, because usually hunters target large-bodied species, and also these are the ones that, for them, it's more difficult to recover from this pressure because they live at low densities and they also have slow reproductive rates. And in this case, what I did is to model the probability of surviving local extirpation separately from the declining abundance in a harder modeling approach. And then I combined it, cross-validated, and so on. And then I projected a model for each of the IUCN mammal ranges across the tropics and stacked all the maps together to produce a hunting-induced defaunation map. We derived this index of defaunation, which is basically back transforming the response ratio to the original scale, but inverting it. So then high defaunation index indicate that an area which is fully defaunated, and then lower values indicate areas that become more and more, let's say, pristine. And we consider that everything under 0.1 represent areas with intact populations. So we produce some partial response plots for the main drivers of hunting pressure. Here, what you see in the y-axis is the probability of surviving local extirpation. And we see that this increases with the distance to hunters' access points, increases with human population density, decreases with human population density and with body mass. And then it increases with the prevalence of stunting or child malnutrition. So basically, in areas where there are poorer communities, these are not the ones that are exerting a major pressure on wildlife populations. And finally, we see that the probability of surviving local extirpation is higher inside protected areas. And for the continuous part of the model, which is the change in abundance, here what we find is an interaction between the distance to hunters' access points and body mass, so that the larger body species are effectively depleted in the proximity of access points, whereas small-sized species become more abundant, and this may be due to ecological release from competition and predation because of these large carnivores disappearing and so on. So basically, these rodents or small-sized species are becoming more abundant in the proximity of hunters' access points. Also, again, what we see is a decline in abundance for areas with higher human population density. So we projected the models across a space for circa 4,000 mammal species, and this is the patterns that we find. In blue, you see areas which are kind of intact, you see Borneo and the Amazon basin and so on, and yellow to red are areas which are under some degree of defaunation. And in total, everything that is above 0.1 is defaunated to some extent, and this accounts for 50% of the pantropical forest area, which might be under hunting pressure. So here, keep in mind that I'm averaging out across all species, and this includes a lot of small-sized species, which account for 60 to 70% of all mammal species. When we focus on medium-sized to large-sized species, the picture changes quite a bit, and then we start to see redder areas in Central America, Colombia, parts of the Atlantic forest, West Africa, and Central Asia, and also here Java and so on. In this case, when we focus on medium-sized to large-sized species, which are the species that are actively hunted, we estimate that 60% of the area or to 80% might be under some degree of defaunation. And particularly in the case of large-sized species, there are many which are around this level of defaunation index, which equals to 70% or more decline in abundance. So we used this threshold to pinpoint hotspots of defaunation across the tropics, which are areas with a high percentage of species with a defaunation index of 0.7 or more. And in these areas, we see some of the most endangered or threatened species by hunting pressure. And in this case, in the case of the pangolin, if you don't know, it is one of the most trafficked species in the world. The scales that you see here are heavily used in the Chinese traditional medicine. And actually, Asian pangolins are on the verge of extinction, and there's a massive illegal trade of pangolins from Africa to China to meet the demand by the Chinese traditional medicine. Also, when we confronted our defaunation maps with intact forest landscapes or the Human Footprint Project, if we do it for all species, we see that there are some pockets that could be not as intact as we would expect based on the satellite images and on the Human Footprint Project. And this becomes even worse when we focus only on larger species, with areas like the Congo Basin being projected by our models. I mean, let's remember that these are model projections, that they could probably hold populations of large mammal species which are at reduced abundance or functionally extinct. So from here, I'm going to move to how we have used these models in combination with land use change and habitat loss approaches to see the combined effects of both threats on animal populations. And here I'm going to talk about two papers. The first is done at pantropical scale. I think I moved this. And this is a collaboration with Juan Gallego Zamorano, who is about to finish his PhD thesis in Radboud University. And here what we did is to use a deductive approach in which we estimate the areas that are suitable habitat within the IUCN ranges based on the habitat preferences. And then we, from that range, we extract the land use that are anthropogenic or not suitable for the species. And we combine this with my models based on the probability of becoming extirpated to estimate also the area that might be lost by hunting. So basically, within the range of the species, you could have areas which are unsuitable based on habitat preferences, but also areas that should be suitable, but because of hunting, they become unsuitable. And we were interested in understanding the area lost by these combined effects. So here you see the relative area loss for species of different body size. Overall, across all body sizes, land use is a major driver of area loss. And only for the larger species, hunting becomes a driver of area loss, or by indicating areas that should be suitable, but they are not because of heavy hunting pressure. When we have both effects combined, what we see is that overall species distributions are reduced by 40% or more on average within their geographic range. And we can see this also spatially for different examples. Here for the spider monkey, which is a species heavily affected by land use change, mostly deforestation. This is an arboreal species, and of course, it demands having a proper forest cover within the range to be able to use those habitats. So because of deforestation, these areas have become unsuitable. And in the case of the lowest monkey, it's mostly affected by hunting pressure in West Africa, because in these areas which are heavily populated and with a large density of settlements. And here, this is an example of a species that is affected more or less equally by the combination of the two main threats. So if we combine all these across species in the tropics, we could derive these maps of hotspots of area loss and cold spots. And again, we see that areas in Central America and Venezuela, but also Atlantic forest and the Chaco or West Africa are areas where species are having less area within their range that because of the combination of these two threats. And this area, the Chaco, is what we were assessing in this next project. This is a collaboration with Alfredo from Humboldt University. He did his thesis and trying to understand the impacts of both habitat loss and hunting in the Chaco, which is the main dry tropical forest in the world. This is a frontier forest where there's been a massive deforestation in the past year due to cattle ranching and soybean expansion. And there's a lot of retaliatory killing by ranchers of jaguars, but also there's hunting of other emblematic species like the Chacoan peccary or the tapir. Here, instead of using a deductive approach, we actually use an inductive approach. So we we fitted habitat suitability models using a large number of occurrence points collected during 30 years. And then we also digitize all possible subsistence ranches in the area. Well, I didn't do it, but they did. But this was a major effort. And then the idea was to estimate which areas could be considered core areas for this species based on on good habitat and no hunting pressure, and then also try to identify areas affected only by hunting, poor habitat, or both threats together. So we did this for the 48 large mammal species, stacked all the maps, and then we assessed the change in core areas from the 1985 to 2015. So what we see is the following. On the top, you see the impacts of land use change due to cattle ranching, and then below of hunting pressure. This is for 2015. And the map depicts the number of species affected by each of these threats in different areas. And here on the right, you see the change from 1985 to 2015. And we see that it's mostly, this is Paraguay, this is Argentina, Bolivia, and Paraguay. So mostly in Paraguay, there's been a massive deforestation and conversion to pastures for cattle. And there are some pockets where hunting pressure has increased or affects more a larger number of species nowadays. And overall, both threats have expanded across the Chaco, over 40% of the area. If we map both threats simultaneously, again, you see in purple those areas affected by the poor habitat and high hunting pressure. And this is what I was trying to show you before. Here in the 1980s, there was mostly pressure derived from hunting activities across roads, but these roads open opportunities to settle and expand and convert the area to pastures, so that nowadays these areas are now affected by both threats. And finally, we can see which species are affected by only one of the threats or two of the threats in this kind of plots. And some of the species affected by both the expansion of deforestation and also increasing hunting pressure are jaguar pumas, which are large carnivores, but also ungulates such as the gray-broched deer and the collared peregrine. And as I was pointing in my previous slides, we see that Bolivia is the country which has suffered most habitat destruction. But I mean, I think it's worthwhile to note that in Argentina, much of the deforestation happened before the 80s. So this is something that we couldn't capture in this analysis. So I'm going to move to the last part of the talk, which is what are the consequences of all this defaunation on tropical ecosystem functioning, mostly on the loss of large frugivores, which perform very important roles in tropical ecosystem due to via seed dispersal services. So around 80 to 90% of tropical plant species depend on animals for dispersal and to be able to recruit new seedlings which will become adults in the future. And the idea is that from an initial community, if we lose those major vertebrates, tapirs, and spider monkeys, or even toucans, this could cascade into a change in the composition of tropical forests because of disruption on seed dispersal services. So the idea is the following. In the plant cycle, there are different stages, some of you know. Here what you see are mutualistic frugivores that are key for performing roles such as fruit removal, and allows the seeds to disperse to a certain distance from the parent tree. From there, the seeds will germinate, leading to seedlings, which will establish and then eventually will become saplings and then adult trees. But there are other actors in this process which are antagonists, like these predators. This is the case of a neotropical forest, by the way. You have peccaries, and you also have squirrels and other rodents like agoutis and pacas that predate on these seeds. And to complicate things a bit more, some of these species are scatter hoarders. That means that some of the seeds will not be predated, but they will be caught somewhere else and may become a seedling eventually. And also you have dung beetles who also perform these roles, and they could aid in forest regeneration via secondary dispersal. And you have also herbivores that may feed on seedlings, so having also negative impacts on this whole process. In the faunated forest, all these processes may be altered because of extirpation of some of the species that perform some of these roles, and some of them may become overabundant, as we have seen in previous slides, and others may be reduced. So all these processes may be altered, and my idea was to try to understand if we can unpack all these processes and come up with an estimate what will be happening in the faunated forest versus intact forest. And for that, I figured that I could collect all this kind of data on the fruit removal, the seed predation, and so on, which has been measured in multiple studies across the tropics throughout the years, and again, build these effect sizes to compare whether this fruit removal or seed establishment and so on is reduced in the faunated forest versus intact forests. So this is what I've been working in the past years, and it's a massive project. It's taking quite a long time, but so far I have collected data for these different phases, and of course the most represented one is establishment, and this is the distribution of all the studies where these kind of processes have been studied in semi-natural experiments comparing defaunated versus non-defaunated forests, and also fragmented areas versus continuous forests. And I didn't include any experiments. So there are some studies that set exclosures to avoid that some species may access the seeds, but I wanted to understand if what's happening kind of in a natural setting. So what we're finding is the following. For some of the stages in the plant cycle, we see a reduction in fruit removal, dispersal, predation, and so on, compared to intact forests. Also in the establishment, there's around 40% to 70% decline in these processes when we back transform to the original scale, except for secondary removal, which we don't see a change, or, I mean, of course, we have large confidence intervals as well. And this process is performed by this kind of species, as I was mentioning before, which are the rodents. And if you remember, these are the guys that become overabundant in areas under high hunting pressure because they're usually not hunting, and they have massive, they have high reproductive rates. And then if other species are gone, of course, this becomes an opportunity for them to expand their populations. Also, the theory tells us that the seed shadow, so how far the seeds can be dispersed in distance, may change from non-defaunated to defaunated forests, where here the large frugivores are becoming less abundant or disappear, and these are the ones which are performing the longer distance dispersal of the seeds. In many cases, in the faunated forest, if these frugivores are gone, most of the fruits will fall under the parent tree, and the seeds will emerge here, and the seedlings as well. So I also took a look at this for seed dispersal and seedling establishment, and what we are finding is that in defaunated forests, most of the seeds are effectively being dispersed. They're not being dispersed, they just fall under the parent tree. Most of the seedlings are being established under the parent tree and away much less than in intact forests. And this is problematic because when you establish here, you have problems with negative density dependence and competition with other conspecific seedlings. And then in many cases, seeds are attacked by pathogens. They're not viable eventually, as Jansen Connell stated in their hypothesis some time ago. And finally, this is something which is very new. I also tested whether those species that have the large seeds are the ones that are or it's more difficult for them to establish in defaunted forests in this graph. So here again, the effect size when it's negative means that their establishment becomes lower as the seed length becomes larger. And this is important because these large seeded species are the ones which have the larger root density, and that means that they are able to capture and store more carbon in tropical forests. So basically what we see here is because of the disappearance of some key actors or some large frugivores in tropical forests, this can lead to a series of cascading effects on some of the ecological processes they perform, and this can cascade to even the capacity of tropical forests for storing carbon. And this is a very beautiful picture that depicts this process from Carolina Bello and collaborators, where from a non-defaunted forest with all the frugivores and so on, if we go to a defaunted forest, this would change eventually the composition of the forest, which would be detrimental for the carbon storage capacity of these forests. They did this nice paper some years ago where they simulated, they compared the random extinction of the random extinction of tree species in different areas across the Atlantic forest compared to the extinction of large-seeded trees and what this meant for the carbon balance. And they saw that indeed, as more species are being lost, the result would be that probably this forest will be less able to capture carbon, and this has implications for climate change mitigation and so on. So this is what I'm trying to unpack in the next coming years. I mean, there's a lot of work to be done. Here what you see is a map of carbon density, and you see that the areas where most of the carbon is stored in terrestrial ecosystem are the tropics. So of course, deforestation will be still the main problem for carbon storage capacity, but indeed, we cannot assume that intact forests are going to be doing the job if we are continuously extirpating the main animal populations in them. So to recap, I don't know what's the time? Okay. So to recap the talk a bit, what we have seen is that we can use human accessibility as a proxy for hunting pressure. I mean, it's not perfect, but it's something that we can use to have a first estimate or areas that could be under overhunting. With these models that I have built, we estimate that 60 to 80% of the pantropical forest zone could be defaunated. Also, it's important to understand that having an intact forest or a high forest cover doesn't mean that the ecosystem is intact, as it could be holding populations of animals that are reduced below current capacity. Then we have seen that there are complementary effects of land use and habitat loss on the hunting, and in some areas one of the threats is acting, in others the other threat, but there could be areas where both of them are acting, and they could have synergistic effects on animal populations, which, in my opinion, are still not well resolved. And well, overall, I've shown how defaunation can affect for regeneration in the tropics. Of course, during these years, I've collaborated with a lot of people. This is a map of the locations of some of the people with whom I have co-authored papers. Most of them, of course, are in Central Europe, and some of them in Spain, only one in the museum, but I hope this will change in the coming years because I'm going to be working here. And these are some of my main collaborators from different institutions where I have worked, or well, some of them I have worked and others no, I just collaborate with them. Jago is now a new PhD student in my lab, and he's going to be building upon the work I've been doing on my defaunation models, expanding the work to other mammal species and to bird species as well, and also trying to understand what are the implications of this also for the structure of plant-animal networks. And these are the papers that I have been showing you today, and if you want to know more about them, please send me an email or a DM, and you can check also my website. With that, I would like to take any questions you may have. Thank you.
Okay. I wonder about, from the first part of your talk, I wonder if you could test the predictions of your models by following how the diversity of animals have changed in the local food markets.
In the what, sorry?
Local food markets. Because the diversity must have changed if the tapir is not anymore in the local food market.
Indeed, there are many studies that instead of focusing on the consequences of this activity for the abundance, they look at extraction rates, basically how indeed the composition in local markets have changed over time. Or just the harvest rates of local communities. But the problem with this is that you need time series. I mean, also with my models, they are based on a space for time substitution approaches. So it's very difficult to have a long-term study that where you have the population abundance or the composition of the species in an area, and you can track it in time, which would be ideal. So you cannot really compare. I mean, you could do the approach that you mentioned, but I don't know if like validating or testing, which I think is what your question is about, could be possible.
At least contrast one evidence with the other.
Yeah, but I mean, I've been with one of my collaborators, Daniel Ingram, in his thesis. He was collecting all this data on biomass extraction rates. And they're about to publish a database on this, and we've been talking for years or confronting both if we fit predictive models of extraction rates and compare them with what I've seen, whether there's some kind of match in our estimates. But yeah, that's been going on for years. I mean, this kind of approaches take a lot of time to collate all the data and so on. But yeah, it's super interesting, of course.
And just one more. Have you thought about, I suppose, to connect all this hunting data and things like that with the emergency diseases and the frequency of emergency diseases in these places?
Yeah, I have an ongoing collaboration with people from the National University of Singapore, and they were interested indeed on trying to predict or map pandemic risk due to hunting and trade. And this is a paper that we have been submitted to a journal recently, and we'll see, it will be published. I mean, it's a very, I'm going to say simplistic. I mean, it's not, I'm not a disease ecologist, and of course there are better ways to address these issues, but it's a first idea of how hunting could, and in which areas there could be a risk of pandemic potential, for sure. Yeah, thank you.
Thanks. Questions? Thank you very much for your talk. You convince us beyond doubt that hunting defaunate the earth. But I wonder what the current hunters would you say about your talk? I mean, they argue they are required to keep the population, the rabbits population, the boars population, and we should pay them to keep hunting. Which is the absolutely contrary with your message.
Yeah,
Have you tried
you're talking about the situation in Spain and in temperate areas, I guess, no? So because, yeah, what you're saying is when you have populations that are overabundant, no, of rabbits and wild birds. Yeah, but I think these are not comparable because I'm talking about the situation in tropical communities, which live in very remote areas and basically they hunt because they need to. Well, they need to. It's their main source of protein and their main source of income. And in the case that you are proposing, I think is the Spanish case, I guess, where you have areas where rabbits are becoming overabundant and wild boars. And here hunting is regulated. You need a license. You need to be associated to hunting estates. And then in many cases, there are conflicts between some of these species and maybe crop production. So I think the two cases are not comparable. I mean, I could give you my opinion about it, but maybe later in a more informal setting.
Well, you know that in the small village in the jungle, they say they use more or less the same arguments. They say they must control the wildlife, don't destroy their plantations, are the same sort of arguments.
You mean about the...
In a village, in a good people, you talk with people.
Yeah, well, you have cases of elephant raiding crops and so on. Yeah, that's for sure. Yeah, I mean, I think every context is different. I mean, you cannot generalize that if we don't control wildlife, they're going to be raiding our crops and so on. I mean, you have areas where this doesn't happen, and areas where there's, as I mentioned in my talk, retaliatory killing because of jaguars eating the chickens and so on. In many cases, it could be because actually the base prey is depleted because of hunting, and jaguars, for example, I'm now shifting to another species, but they need to feed on domestic prey to be able to maintain. But I'm not a social scientist, and I mean, what I try to show is the picture based on the data of how these activities are affecting animal populations. And of course, ideally, I know a lot of studies that have worked with local communities to assess the sustainability of hunting and how they can shift from some species to others based on the population size, and then be able to, because in the end for them it's also detrimental that these populations are disappearing because they depend on them. So, yeah. I think,
Okay.
but happy to discuss more later.
Thank you, Anna. Really, really nice talk. I have two questions. You mentioned in the beginning that this wild meat is brought to the markets. So basically, people eat this meat because local people eat it, and then the people from the cities, I understand that they use it more like a luxury thing. Is there any quantification of what of the two or maybe other uses of this wild meat is? Also, I heard recently that a lot of meat from Congo arrives to Belgium, I think, in Europe.
The UK. Yeah, I mean, these are wealthy people, sometimes from African origin, that they kind of miss what they ate growing up, basically, and then they demand this kind of not only meat for eating, but also like products like hands of some primates for ornamentation, for decoration of their houses. But yeah, the issue is that also in some cases when you have a dinner and you basically can offer your guests something that is wild meat, which is really exotic and is really expensive, is a way of showing status. This happens also a lot in China as well. Or using tiger bone, for example, for some drinks and so on. This is kind of showing status for business dinners and so on. And yes, that's for outside, I mean, outside of Africa, but in Africa itself, in urban settings, you have also people that grew up in rural communities, and then they move to the city, but they still demand to eat some of the wild meat that they cannot access anymore because they don't hunt anymore, but they want to buy it and they want to consume it. So if you have transportation corridors that allow hunters to, hunt or capture the species and then trade the wild meat with intermediaries that can bring it to the city, then it means that they are going to shift from only hunting for subsistence purposes to basically commercialize the meat and get an extra income. And I don't know if I address all your questions.
Yes, but my second question is about the dry forest. So it seems your studies are mostly based on rainforest.
Yeah.
Is there any data on dry forest?
There are some data in savannas and in some forests which are drier, but most of the studies have conducted in wet tropical areas. So basically here we are kind of extrapolating a bit to ecosystems that we don't know about, but I think the drivers are similar, and the species included in the analysis are very similar to those included in my database.
Because, I might be wrong, but maybe the dry forest is a bit more sensitive environment, so then maybe the effects could be bigger there? But maybe no, I don't know.
I guess first thing is that it will hold a less number of species. But yeah, I mean, there are very, very few studies in dry forests. And I think the work from Alfredo is one of the first ones that is kind of putting dry forests in the how you call it, the hotspots, in the spotlight, sorry, in the spotlight, yeah, because when people talk about tropical forests, they normally work on moist or wet tropical forests. And here his thesis was about making a case for the Chaco. Well, the northern part of the Chaco is rainforest, but the rest of the area is pretty much dry forest.
Thank you.
Thank you.
Okay, any more questions? I'm just going to squeeze, but I'm going to put just a small one because you've already talked about this problem of space by time substitution. But when you were discussing about bush meat, I was thinking about some conversations we had that the difference between meat markets in Africa and markets in certain parts of the neotropics of South America, and where in places where you have more settled people for a longer time, that's more normal. And in the places where people arrived in a few decades ago, the consumption is different. Do you know or have you thought out or tried to analyze data on this issue on the time since human settlement, the effects on the foundation?
That's one of the main issues that in some cases you know it. I mean, the studies report that the settlement's been there for 30 years or 50, but in most cases it's impossible to know, and that's a pity. But what we see, I mean, of course, in Africa, the communities have been established for longer, mostly. But in the neotropics, what we see is there is mostly a lot of colonists coming in. Well, you know it.
It's a Wild West.
Yeah, because of a road built for oil exploration, and then they start to settle along the road. And there are a few studies looking at the compared impact of the indigenous communities and the colonies coming in. And many of them, they don't hunt because they need to, because they work for the oil company. They hunt, well, maybe they eat some of the wild meat, but sometimes it's just for recreation. Yeah. So this is an added impact on the populations, on top of what the communities have been, I mean, they do normally for their subsistence. But yeah, in the tri-frontier between Colombia, Brazil, and I believe it's Peru, there's a lot of, I mean, it's a market which is booming, and there's a lot of trade over there. And as more roads are built, areas become accessible, you see more people settling down. And
And the declines of populations are faster than you see in Africa, where the people need the protein as a source.
I mean, I don't know again in time, like the temporal trend, but for the first paper I presented on the meta-analysis, we had I didn't show it. We compare the effect sizes for the different regions. And I think there were not major differences between them. There was no an issue, but yeah. But indeed, I mean, what's needed is long-term monitoring, as in every ecological study, So yeah, and also, well, in the case of the neotropics, what happened was during the rubber boom, there was a lot of pressure on mammals mostly. During the first part of the century, and also there was this industry. I don't know how you say it in English. Skins from jaguars and so on.
Leather.
There was a lot of demand from the U.S. So these populations had suffer a lot of pressure these years, and this is stabilized now. And what we're going to be working in Brazil in the next years in an area where now hunting is still occurring, but probably what we see is the signatures of what happened in the past. But it's difficult to tease apart the effect of contemporary hunting compared to past hunting pressure.
Thanks. And then, well, thanks a lot, Anna, for a very nice talk. And we can, if you want to continue chatting with her, we are heading to the kiosk for some drinks.
Okay.